So just a little bit of review what we did in this lesson before we finish. We only have one example left to finish. Okay. So we talked about a new way to find missing sides and missing angles in right triangles, depending on the information we're given. And that was a type of trig ratio or trigonometric ratio called tan. First of all, we talked about coming up with a couple of new names for sides in right triangles. What is the length of the side opposite angle A in this figure? 9. What is the length of the hypotenuse? 15. Pretty easy to recognize. What is the length of the side adjacent to angle C? That's opposite angle C. 13 is not there. It's 9. Remember I said how to locate the adjacent? Eliminate the opposite side first. 12's the opposite. 15's the hypotenuse, so the remaining one must be the adjacent. Okay? Yeah. Hello. Never. Never. Yeah. Yeah, I'll never ask you on a question like this what side is opposite angle B, because we talk about the acute angles. Okay? Then we talked about a special type of ratio called the tangent ratio. And it's the ratio of a side opposite the acute angle in a right triangle over the side adjacent. So, going this one here, what's the tan of angle A? It's going to be a fraction, which you can make into a decimal. The tangent of angle A, or the tan of angle A. 9/12, because it's opposite over adjacent, which does, yes, reduce to 3/4. Whoops, tan A. What's the tan of angle C? 12/9, or 4/3. Okay? Because it is opposite over adjacent to C. And yes, that equals 4/3, or sorry, 3/4. So, and then the third thing we did was to actually go ahead and find the missing angles. Okay? We talked about how to write the tan of angles in a right triangle, but then we took it a step further in order to find the actual missing angle. If I wanted you to actually find the missing angle C, what would you do from here? Do you remember? How do we get C by itself? How do we get tan rid of tan? Tan, sorry, inverse. Which means I got to take the tan inverse of the fraction. And it doesn't matter if you take the tan inverse of 12/9 or 4/3, it's still going to give you the same answer because they're the same fractions, or they're the same value fractions. And what do you get if I asked you to round it to the nearest degree, the whole number? What do you get when you actually do tan inverse 12 divide 9 and round it to the nearest whole number? Sorry? 30. I can't hear, guys. 53? Is that right? 53? Okay, sorry. You did A. Yeah. Okay, so that's everything we've covered so far in this lesson. So let's just look at this last example where we can actually use trig. Okay. when you encounter a question like this, it's always good to sketch a diagram of it, right? And the diagram must include a right triangle, because that's the only time that you can do trig right now. That's the only time we know how to do trig. So we've got a ladder that's 10 feet long that leans against the side of a building with a base that's 4 feet from the wall. What angle to the nearest degree does the ladder make with the ground? Okay, so we've got some building. We've got the ground coming out here, and we've got a ladder. So notice the side of the building, the ground, and the ladder form a right triangle. Or we assume that. We have to assume that. So we assume the ground is perfectly flat and that it's perpendicular, meets at a 90 degree with a perfectly vertical wall. So let's fill in the information we know. What sides do I know? So the ladder's 10 feet. Now, which one is the 4 feet? This or this? The bottom is 4 feet. And then we want to label the missing angle that we're trying to find with a letter. You call it whatever letter you want. Let's just use X. Which angle is the one I'm asked to find? Well, this one obviously is 90. Is it this one or this one? The ladder makes with the ground. Has to be this one. This is our X. So we're going to have to use trig. We're going to have to use tan. But what's the problem here? Like to set up an equation, it's the tan of the angle, which in this case is missing, X, is equal to the opposite side over the adjacent, right? What's the problem here? Yeah, we don't know the opposite side. But can we figure it out? Of course. If we know two sides of the right triangle, we can figure out the third side using Pythagoras. And then we can do trig to find the missing angle. So one side squared plus the other side squared, or legs squared plus legs squared, equals hypotenuse squared. Make sure you fill in the correct numbers in the correct spots. So one of the legs is missing, so I'm just going to leave it as a squared, plus the other leg, which is 4 squared, equals the hypotenuse, which is 10 squared. So that gives us a squared plus 16 is equal to 100. Subtract 16 from both sides, a squared is equal to 84, which means to find a by itself, I just square root both sides. And let's just round it to the nearest tenth or 1 decimal place. Square root of 84, 9.1 or 9.2? 9.2. Now we can use the trig. So how do we do the trig? We're always going to set a trig up that it's going to be whatever the trig is. In this case, you only know tan. Then the angle equals one side over another side. The equation's always going to look like that. So in this case, we know tan of the angle, which in our example is X, equals the opposite side X, which is, sorry, 9.2, over the adjacent side, which is 4. And now we solve that equation. That's really what trig is. It's equation solving. It's just a new type. So how do I get rid of tan? I got to do tan inverse to take those out, which means I got to take the tan inverse of the fraction on the right side to get my missing angle. And I am asked to nearest degree, so nearest whole number. So tan inverse of 9.2 divide 4. 67. Second person confirm that. There we go. Okay. Now, one thing I want to talk about before we just wrap this up is tan x does not mean tan times x. Okay. Tan, you got to think of tan like it's an operation. Okay. So you don't get rid of tan by dividing tan. That's why we do tan inverse. Okay. Like if I asked you to find the square root of 25, you wouldn't go square root times 25. The square root is the operation, right? This is the operation. So something to keep in mind. To get rid of just tan, we always do tan inverse. And then we're going to learn two other ratios, and we're going to get rid of them by the same way. Okay.